Okay, so without further ado, let's begin our class here with Surah Al-Fatiha. Okay, so today we'll start with module 6. Okay, so in this module 6 here, you will learn about shift and rotate. Right, so there are a few instructions regarding the shift and rotate. Okay, you will learn about all that instruction in the next few slides. Okay, so the first instruction that you're going to see here is what we call it as a logical shift left. All right, so this logical shift left used to shift all bit in RD one place to the left. Okay, bit 0 is cleared while bit 7 is loaded into the C flag of your status register. Okay, so this operation actually effectively multiplies your signed and unsigned value by 2. So every time you do the LSL means that you're going to multiply the value inside of that register by 2. All right, so this is the operation. Okay, you can see here 0 from outside go to your bit 0, and then what happens is all this bit here will be shifted to the left by 1 bit, while bit 7 will go to your C flags. Okay, so this is the flag that are affected after you execute the LSL instruction. Okay, so you have 6 flag affected, which is H, S, V, and Z and C flags. Okay, let's look at this example how the LSL works. So this is my LSL. Okay, so this is LSL. So what happened is for the LSL, right? So this is my bit 0 and this is my bit 7. So 0 from outside will go to your bit 7. 0 from outside will go to your bit 0, and then all the bit will be shifted to the left by 1 bit, while bit 7 here, the value from bit 7, okay, will go to your C flags. Okay, so this is what the LSL do lah. Right, so let's look at this as example. You have LDI R16 OX33. What happened is, so inside of your R60, you have this value here, which is 33. Okay, so R16 equal to, okay, for this kind of question or instruction, you need to convert this hexa here to your binary number. Okay, so by converting 33 to binary, so you will get 0011, 0011. So this is your bit 0 and this is your bit 7. Okay, next, what happened is LSL R16. So you're going to do a logical shift left to your R16. So this is the initial value of your R16. Okay, so what happened is, so 0, okay, from outside will go to your bit kosong kat sini. Alright, so 0 will go here, and this one here will be shifted to the left by 1 bit. So this one go to here, and this one here will go to the next bits at the left. 0 will go here, 0 here will go to the next bits here, and then the rest will be shifted to the left by 1 bits. Okay, what about your 0 yang ni? Okay, so this 0 here will go to the C flags. Okay, so this is your R16 value. So sekarang ni what happened is the R16 value is 56. Okay, previously your R16 is 33. Okay, so when you So DS, okay, you see here, okay, the LSL used to multiply signed and unsigned value by 2. So if you can see here, so 33 you multiply by 2, you will get 66. So, okay, so this is what the LSL do. Okay, so this is another example lah. Okay, so I just skip this example here. Okay, you can see it by yourself. Okay, for this example. Okay, next we are going to look at the LSR. Okay, so LSR stand for logical shift right. So this instruction shift all the bit in your RD. Okay, one place to the right. Okay, so now you're going to shift all the bit to the right by 1 bit. Bit 7 is cleared, while bit 0 is loaded into the C flag of your status register. Okay, so this is your LSR. So apa yang berlaku is, okay, so this is your register. 0 from outside will go to your bit 7, while this one here, any value from bit 0 will go to your C flag. Okay, so this operation effectively divide an unsigned value by 2. So every time you use the LSR means that you're going to divide that value by 2. But this one here only for the unsigned number. Okay, so this is divided by 2 and this one is multiplied by 2. Okay, so this one can use for both unsigned and signed number, but this one only for unsigned numbers. Okay, next. So we have, let's do example here, LSR R16. Okay, so this instruction here is executed sequentially. So by right now, our R16 have new value which is 66. Okay, so what you're going to do is we're going to do the next instruction that is LSR R16. Okay, so what happened? Okay, so 0 from outside, okay, will go to your bit. Okay, I just okay, so 0 from outside will go to your bit 7, and this bit will be shifted to the right by 1 bit. Okay, so this one becomes 0, 1, 1, 0, 0, 1, 1. What about this 0 here? Kosong yang ni akan masuk to your C flag. Okay, so C sekarang ni get new value 0. Okay, so this is your R16. If you convert this value here to R16, what happen is your R16 now will have what value here? Sama dengan 33. Means that from 66, you divided by 2, you get back the 33. Okay, so this is only valid for the unsigned number lah. Why unsigned number? Because this one here, you see, if your signed number is 1, what happen is, okay, contoh lah, bit 7 is 1. Okay, you have a signed number. Okay, which is bit 7 is will determine either you are a signed positive number or negative number. Okay, let's say this one is a negative number, so the bit 7 is 1. So when you do LSR, what happens is this one here will shift it to the right. Okay, what about bit 7? Bit 7 now become 0, which is cannot use lah for signed number. Okay, so this one only valid for unsigned number if you're going to divide by 2. Okay, so that is for the LSR, logical shift right. Okay, so this is the what we call here the flags that are affected after you execute this instruction, the LSR instruction. Okay, next we'll move to the next slide. Okay, so this is another example. Okay, you can do it by your own. All right, so now we're going to the ASR. Okay, so what this ASR do? Okay, so ASR stand for arithmetic shift right. Okay, so this instruction shift all bit from your RD one place to the right. Okay, similar. Okay, you're going to shift one bit of your value from your register to the right, and but okay, bit 7 is held constant, means that you copy back your bit 7 value, and bit 0 is loaded into the C flag of the status registers. Okay, so this is ASR. Okay, so this is your bit 7 and this is your bit kosong. Okay, there is question here. Okay, Chuan Sing Lang asking, will the V flag be triggered if the value 1 go past bit 0? Value 1 go past bit 0. Okay, I think the V flag only be triggered if there is an overflow from bit 7 to bit 6, not bit 0 to another bits. Okay, from Josh, okay, for LSL, it will also affect the sign number, right? For the LSLs, for the logical shift left. Yes, for the logical shift left, okay, you can use it to multiply both signed and unsigned number. Okay, and then Tan Ying Kwan asking that if change bit between D3 and D4, which hash get affected? Yes, every time you move, okay, there is a carry move from bit 3 to bit 4, and then the hash will get affected. Okay, now we're going to see what the ASR do. Okay, so this is ASR. So what happened is bit 7, okay, you copy back your value of your bit 7, while this bit 0 will go to your C flags. Okay, let's look at the example here. Okay, you have ASR R16, for example. Okay, so the current value of R16 is 33. Okay, so this one here, okay, so what happened is this is your bit 7, so you copy back the value of your bit 7. Okay, and then the rest of the bit you shifted to the right by 1 bit. Okay, so kosong, this kosong here will shift it to here, so become kosong. 0 will go here, and then followed by this one here will go here, 1, 1 will go here, 0, 0, 1. What about this one? Okay, so this one will go to your C flag. Okay, so this is your new R16 value. Okay, which is equal to 19. Okay, if you see here, for the ASR, okay, this operation effectively divide a sign value by 2 without changing its sign value. Okay, so for this one here, ASR, okay, used to divide it by 2 for sign number. Why? Because you copy back any sign from your bit 7. Okay, you see here 33. Okay, you press the calculator, 33 in hexa divided by 2. Okay, you will get 19. Okay, so this is the flag affected, only 5 flags affected, which is S, V, N, Z, and C. Okay, so this is another example lah. Okay, you are going to load R16 with minus 68. So what happened is, now this is minus 68 is actually the decimal number, so you need to convert to your binary. Okay, so to convert to binary, you need to do the second complement. So this is the value for the negative 68, okay, for the binary number. And then you're going to use the ASR R16. So what happens is you copy back the bit number 7, okay, here. And then after that, you shift all the bit to the right by 1 bit. So this one becomes 1, 0, 1, 1, 1, 1. And this 0 here will go here, 0, while this 0 will go to your C flag. Okay, so this is for ASR. Any question up until here? Yes, for the ASR, you can work with both signed and unsigned number because you copy back even though you have a unsigned number, okay, which is the bit 0, the bit 7 is zeros, okay, then you copy back the bit 7 and the value of your value still in unsigned number, okay, because bit 7 remain 0. Okay, for the ASR, the sign bit won't change. Then how overflow occurs? Okay, so for that one, I need to run in AVR Studio to see whether for the this for the ASR lah, either the V flag is changed or not. Okay, the overflow occurs or not. Okay, I need to double confirm on for the ASR for the overflow flags. Okay, next we go to what we call here. Okay, the next instruction is ROL. Okay, so ROL stands for rotate left through carry. Right? So this instruction shift all the bit in RD one place to the left. Okay, you're going to shift all the bit one place to the left. The C flag is shifted into the bit 0 of RD, while bit Z7 is shifted into the C flag. Okay, so now you have two C flag. One is old C flag, the other one is the new C flag. Okay, so I lukis dulu. Okay, I draw what happens when you do the ROL. So for ROL, okay, you have two C here. Okay, one is C new, and the second one is C old. Okay, your C old will go to your bit 0, and then this bit here will be shifted to the left by 1 bit, while bit 7 here, okay, any value from bit 7 will become your C new. Okay, C only means that the C from the previous instruction. Okay, that is the C old. Okay, let's look at the example here. Okay, I just put here ROL R16. Okay, so our current R16 now is 19, and the C is equal to 1. Okay, the previous C. Okay, after you do the ASR, what happened is this bit here will go to your C flag. Okay, so now what happened is the C whole value 1. Okay, so now I'm going to execute ROL R16. So this value here, okay, this one here from, okay, so this is my C old, will go to your bit 7, akan masuk ke bit 7, and this one will shifted to the left by 1 bit. right? So become 1, 0, 0. Okay, so this one become 1, 1, 0, 0. What about this 0 here? Okay, so this 0 here will go to your C new. Okay, so now what happen is your R16 now will have number 33. Okay, so this operation, if you use the ROL, this operation combined with LSL effectively multiplies multi-byte signed and unsigned value by 2. Okay, so this ROL is used when you're going to multiply 16-bit number by 2, for example. Okay. Okay, so this is an example, all right, by using the ROL. Okay, the first line here, SEC. What the SEC do? Okay, so this SEC, you're going to, SEC stand for set the carry flags. Okay, so what happen is C equal to 1. Okay, and then you load this number here, LDI R20OX15. So what happen is R20 will have this value 1, 0, 0, 0, 1, 0, 1, 0, 1. Okay, if you convert it to the binary number. Okay, next you're going to ROL R20. So since your C, okay, the CO is 1, so this C will go to your bit 0. Okay, and then this bit here will be shifted to the left by 1 bit. So that's why they become 1, 0, 1, 0, 1, 0, and 0. What about this 0 here? This 0 will go to your C. Okay, next you do the again ROL. So what happened is, okay, 0 from the CO, okay, from the previous carry will go to your bit 7, bit 0, and then all of this bit here will be shifted to the left by 1 bit. So the new value of R20 is 1, 1, 0, 1, 0, 1, 0. What about this 0? This 0 will become your new C. Okay, and then you do 2 times. Okay, then you have another ROL. So what happen is this 0 here will go to your bit 0, and then the value will be shifted to the left by 1 bit. Okay, so they become 0, 1, 1, 0, and this is 1, 0, 1, and this 0 here will go to your C flags. Okay, so this is what the ROL. Okay. Next, we have the ROR. Okay, so the ROR stand for rotate right through carry. Okay, so ROR instruction shift all the bit in RD one place to the right. The C flag is shifted into bit 7 of RD, while bit 0 is shifted into the C flag. So again, for this one here, ROR, you have two C. One is C old, the other one is C new. Okay, so this is what happened here. So ROR, so you have a C old. Okay, so this C old here will go to your bit 7. Okay, and then you shift to the right by 1 bit, while bit 0 here will go to your C new. Okay, this operand, when combined with ASR, okay, effectively divide multi-byte signed and unsigned value by 2. Okay, means that if you have a 16-bit number, 24-bit number, okay, you need to combine them, okay, by using the ROR if you're going to divide that number by 2. Okay, so let's do example here. Okay, so R16. So what happened is, what is our C old? C old from the previous instruction is 0 lah. Okay, so this 0 here will go to your bit 7. Okay, and then all of this bit will shifted to the right by 1 bit. 0, 0, 1, and this become 1, 0, 0, 1. And what about this one here? This one will go to your C new. Okay, so C new sama dengan 1. Okay, so the value here become 1, 9. Okay, so for this one here, you see the hash flag is not affected. Okay, every time you do the rotate to the right, okay, shifted the bit to the right, your hash flag will not affected. Okay, so this is another example. Okay, SEC, you're going to set your carry bit by 1, and then you have this number here, and then you do the ROR instruction. Okay, so any question for the data shifting? Okay, this is for the data shifting. Okay, you have 5 instructions for the data shifting. Okay, the first one here is LSR. Okay, which is you're going to, every time you're going to multiply the value by 2, okay, you can use the LSL. Okay, this is for both unsigned and signed number. And then you have a LSR, okay, which is you're going to divide it unsigned number by 2. And then you have a SR. Okay, if you're going to divide it signed number by 2, you can use the ASR instruction. And then you have ROL and ROR. Okay, ada soalan tak? Okay, if no question, okay, we go to the next slide. Okay, next we're going to see the BSET. All right, so BSET instruction, okay, used to set a single flag or a bit in your status register. Okay, so this one here, okay, so this is the operation. If you see here, and this is the syntax. Okay, B set S. Okay, S is the location of your bit. If you put 0, mean that is a belong to bit 0. If you put 1, that is belong to bit 1. If you put 7, bit set 7 means that is belong to bit 7. Okay, so what happened is this is the operation. Okay, put 1 to your status register with a location of your S. Okay, for example here, you have B set 6. Okay, so this is your status register starting from 0, 1, 2, 3, 4, 5, 6, 7. Okay, if you put bit set 6, means that you're going to put T equal to 1. Okay, if you put bit set 0, what happen is bit 0 is belong to C flag, so C equal to 1. Okay, which is this one here equivalent sama dengan SEC. Okay, so this is what the bit set do lah. Okay, to tell the CPU to set a single flag in your status register. Okay, next we have the Bclr. Okay, so this Bclr instruction clear a single flag or a bit in your status register. Okay, bit set you are going to set your flags in your inside of your status register, while Bclr you're going to clear the flag inside of your status register. So this is the syntax. Bclr S, which is S is the location of your bit, okay, from 0 to 7. Okay, so this is operation. You put 0 to the location of S inside of your status register. Okay, again, okay, so this is your status register. Okay, you can put the bit number here starting from 0, 1, 2, 3, 4, 5, 6, and 7. Okay, if you use the Bclr 0, means that you go to location 0. Okay, you know that you're going to clear your C flag. Okay, I'm going to clear my S flag. Okay, I'm going to make my S flag equal to 0. So, how to do that? Macam mana nak buat? Okay, I can write out Bclr. Okay, what is the location of your sign flag? Okay, 4. So, you just put 4. Bclr 4. So, automatically after you execute this instruction, your S flag become 0. Any question? Ada soalan tak? Up until here. Okay, if no question, then we go to the next slide. Okay, BST. Okay, BST stand for bit store from bit in register to your T flag in status register. Alright, so this instruction store bit B from your status from your GPR, okay, to the T flag inside your status register. Means that you go to the location of your bit inside of your what we call here your GPR, get that value and store it to your T flags. Okay, so this is the syntax BSTRD, okay, comma B. RD is your GPR, while B is the location of the bit of this GPR. Okay, so what happens is you take any value from the bit of your GPR and put to your T flag. Okay, for example lah. Okay, we continue this one here. Okay, so I just put BST R16 7. Okay, so what happened to my T flag after I execute this instruction? Okay, siapa nak tolong? What happened to my T flag after I execute this instruction? BST R16 7. Okay, my R16 value, okay, this is my current R16 value. 0001 1001. Okay, so what you're going to do is, okay, you go to the bit 7. Okay, so this is your bit 7. Take this value, put to your T flag. Okay, so your T become 0. Okay, for another example, BST R16 3. Okay, what happened to my T flags? Okay, so this is my R16. Okay, this is my R16 and this is my bit 3. Okay, 0, 1, 2, 3. So this is my bit 3. So I take the value here from bit 3 and then put it to their T flag. So automatically your T equal to 1. Okay, so this is what the BST do. Okay, to store from a bit in your GPR to your T flag of your status register. Okay, next we have the BLD. Okay, so BLD stand for bit load from T flag in status register to a bit in your GPR. Okay, so this instruction copy any value from your T flag in the status register and put it to the bit B in your GPR. Okay, so this is the syntax BLDRD, comma B. Okay, D is your your GPR lah from R0 to R31, while B is your bit location from bit 0 to bit 7. Okay, so what happen is you take the value from your T flag and put it to the bit B inside of your GPR. Okay, let's look at this example. Okay, I put BLD R16 7. So what happened? Okay, what happened to my R16? Okay, so this is my R16. R16. Okay, current value of R16 is this value lah. Alright, 19, which is 0001 1001. So now what happened is I go to my T flag. Okay, so this is the current value of my T flag. Get that value and put to the location of bit 7 of my R16. Okay, so this is bit 7. This is bit 7 and this is bit 0. And what happened is this T here I put to bit 7. So now my R16 change from 19, okay, to 99. Okay, so this is what the BLD do lah. Okay, copy the value from your T flag, put to your register. Okay, put to your GPR. Okay, another example. BLD R16 1. Okay, so what is the new value of my R16 after I execute this instruction here? So R16 will become okay, current value of R16 yang mana? This one lah. Okay, this is your R16, the current value of R16, which is 1001 1001. Okay, now you're going to load T, okay, value from the T to the bit 1 of R16. So what happened to my R16? So R16 akan jadi, okay, R16 equal 1001 1011. Okay, why? Because your T masih lagi, okay, the T is still, okay, your T value is still 1. Okay, remains. Okay, so you copy this value here, put to bit 1 kat situ. Okay, so this is your new value of R16. Okay, if you see here, okay, kat flag affected ni, okay, every time you do the BST and BLD, none of these flags are affected. Means that the flag value remains. Okay, if your T is 1, then after you execute this instruction, your T is still 1. Okay, your flag register, your status register flag are not affected. Okay, please do correction ya. This is a BLD, not BST. Okay, tukar ya this one. Okay, any question? Ada soalan tak? If no question, then we go to the next slide. Okay, so we have the SEC. Okay, SEC stands for set carry flag. Okay, so this instruction set your carry flag in your status register. So SEC, what happen is you put 1 to your C flag. So automatic your C equal to 1. Okay, what about the other flag? The other flags are not affected. Only C flag equal to 1. Okay, next we have the CLC. Okay, CLC stand for clear carry flags. Okay, means that you're going to clear your carry flag. Alright, so this is a syntax. CLC, what is the operation? You put 0 to your C flags. So if you see here, okay, only C flag is affected, which is C always equal to 0, while other flags are not affected. Okay, next we have the SEN. Okay, so this one here, you're going to make your negative flag equal to 1. Okay, you see for this one here, okay, your N equal to 1. Others, the value remains. Okay, then we have the CLN to clear your negative flags. Okay, so what happens is you see here, every time you execute the CLN, your N always equal to 0. Okay, then we have the SEZ. Okay, so SEZ stand for you're going to set your 0 flag inside of your status register. So every time you see the you execute SEZ, what happens is your Z equal to 1. Okay, then what about if you're going to clear this Z flag here? So you can use the CLZ instruction, okay, to clear your Z flag inside of your status register. Okay, you see every time you execute the CLZ, so Z flag will become 0. And then we have the what we call here. Okay, this is the commonly used lah. Okay, SEI. Okay, SEI stand for to set your global interrupt flag. Okay, this is used if you're going to use the interrupt programming. Okay, so every time you're going to use the interrupt programming, make sure that you need to 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 set your I flag. Like if not, you cannot do. Okay, you cannot invoke any interrupt. All right, so this is the syntax. SEI. What happened is, okay, you put 1 to your I flags. Okay, you see every time you execute SEI, your I flag always 1, while the rest of the flags here are not affected. And you can clear your I flag. How to clear the I flag? By using the CLI instruction. Okay, so this instruction clear the global interrupt flag inside of your status registers. Okay, so what happen is you put 0 to your I flag of your status register. So you just put 1 your I flag now equal to 0. If you if you don't want to use this what we call here, okay, don't want to use this instruction here, you can always use this. What is the other instruction for this one just now? Bclr ya. Is it? Okay, betul. Okay, you can use the Bclr, okay, followed by bit 7. Okay, so it is equivalent to CLI. Okay, for this one, okay, you can use bit set. Okay, this one you can use the bit set 7. It is equivalent. Okay, with the SEI. Okay, any question? We finish our module 6. Ada soalan tak? Module 6. Any question for the module 6?